So for sum and difference identities, what we're going to be looking at are these 6 different equations. They are on your green sheet already, so you don't have to memorize them, and they are condensed into 3 equations. And what they did is they took 2 of the equations and put them into one line here. So I'll show you how those work. The sine of an angle plus a different angle, so these would be 2 angles added together, is equal to this expression. The sum of a difference of 2 angles, which would be 2 angles subtracted, would be equal to this. They combine those 2 into one line here. Because they are so similar, you can see how they match up. The only thing that they don't have matching is if there's a plus here, there's a plus here, and if there's a minus here, there's a minus here. So what they did is they did plus minus, so that you only had to look at one. For cosine, it's a little bit trickier. Again, it's very similar as far as matching up with the equation, but if it is the sum with a cosine, there's a minus there. So when you see a plus on the top, you'll see a minus on the top, which means if you do the cosine of a sum of 2 angles, if they're added together, you would have to use that top sign, which is a minus sign. When you're subtracting 2 angles, you'd have a plus. Subtracting, you'd have a plus. Similar for tangent. So those are the 6 that we're going to look at and use. How and when do we use these? We'll do example 1. Cosine of 75 degrees. When you look for 75 degrees, it is not on your unit circle. You know, 60 and 90 is, but not 75. So this is a case where we would use, in order to figure out the exact value of this, we would use a cosine of a sum or difference of 2 angles that we are familiar with on our unit circle. So I would look at all of the different degrees, measures that we have and that we use, and I see if we take 30 plus 45, we would get 75. So instead of 75 as a whole, I break it up into 2 parts. It's the same because when you add these 2, it equals 75. But if you have 2 angles added together, then you can use one of these formulas to figure out the exact answer. So here's what I'm going to do. For cosine of 2 angles added together, I'm going to use that third equation. So I'm going to do cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. These alpha and betas represent these 2 angles. So every time I see an alpha, I'm going to use 30 degrees. And every time I see a beta, I'm going to use 45. So cosine of alpha would be cosine of 30. Cosine of beta would be cosine of 45. And then it's minus. Sine of alpha would be sine of 30. And sine of beta would be sine of 45. So basically what I did is I started with the question, I broke it up into 2 different angles that add up to be that, and then since I had cosine of the sum of 2 different angles, I wrote down the formula. Every time I saw an alpha, I did 30, and a beta, I did 45. So that is the next step, and then I need to look all of these values up. So what is the cosine of 30? Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 30 is half. Sine of 45 is square root of 2 over 2. So I wrote all those down, and then I looked up the values, and now I'll just simplify. So when you have 2 fractions, you multiply the tops and multiply the bottoms. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times square root of 2 is square root of 2. 2 times 2 is 4. We have 2 fractions with a common denominator. My common denominator is 4, and then I would just subtract the tops like that. So that would be my exact and final answer.